Alright guys, how many three-digit numbers can be formed using the digits 1, 2, 3, 4, 5? So when you're doing a question like this, what you got to remember first and foremost is how many digits you have to use at the start, okay? Alright, so basically to do this question, what you do is you draw 3 boxes, one to represent each number you're going to use. The first question is if no digit is repeated in the number. So you have a choice. When I put numbers in here, when I put the number 5 in here, I'm not saying that you pick the number 5. I'm saying you have a choice of 5 numbers to go in there. Now that you've used one of the numbers, you now have a choice of 4 numbers for the second one. And then once you use another number, you have 3 numbers to choose for the third number. When you multiply all these out together, you get 60. You can make 60 combinations for 3 digits using 5 numbers. Okay? Now, how many of these numbers begin with a 3? To begin with a 3, you have to start off with the 3. So there's only one choice. You have to choose the number 3. That means there's one choice for the first number. You've already chosen the number 3, it's compulsory. Now you have 4 choices remaining for the second number. Whichever one you choose, there's 3 choices for the third one. This means there's 12 combinations that begin with 3. Okay? Next one is how many combinations are bigger than 300? So to get combinations that are bigger than 300, you have a choice. Your first digit, you have a choice of 3, 4 or 5. It has to be a 300, a 400 or a 500 to be bigger than 300. This means you have a choice of 3 different numbers. Once you choose one of these numbers, whichever one it might be, you still have 4 digits remaining. So it's 3 multiplied by 4. You choose your second digit and you still have a choice of 3 numbers remaining for the third one. You multiply this out. We're expecting an answer bigger than 12 because 12 was 1 second and 24. So 3 by 4 by 3 is actually 26, not 24. Okay, next question. In how many ways can the letters of the words Germany be arranged in a line? Germany has 7 letters. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. You have a choice of 7 letters. 7 letters can go in the first one. Once you use one of them up, there's 6 remaining. Then there's 5 remaining, 4 remaining, 3, 2, 1. What this means is multiply 7 by 6, by 5, by 4, by 3, by 2, by 1. But there's actually a short way of doing that in the calculator. It's what's called the factorial button. So if you write down 7, and what you're looking for is an exclamation mark, okay? So the exclamation mark is over the x to the minus 1. So you press shift because it's the yellow button. And then you get 7 factorial is 5040. So 5040 combinations in total. Now, for the next one, it goes, how many of these combinations begin with G? If you have to choose G, that means you only have one choice to begin with. You have to choose G. After that, you can pick any letter you want. So there's 6 letters remaining. So you have 6, 5, 4, 3, 2, and 1. Once again, this is 6 factorial this time. And you get 720. That's what you'd expect. 1/7 of them begin with G. Okay? Now, what's the probability that the arrangement begins with G? The probability is the number of combinations beginning with G divided by the total number of combinations. Okay? So to do this, what we're going to do is we're going to put 720 and we're going to divide it by 5040. 720 divided by 5040. Okay, a seventh. Alright. Shh. Okay, guys. Next one. It'll still be there. Right. Ben rolls a dice 300 times. How many times do you expect him to roll a 6? Now, on a dice, okay, dices have 6 sides. And only one of the sides has a 6 on it. So every single time you roll a dice, you have a 1 in 6 chance of getting a 6. If you roll it 300 times and you multiply it by a 6th, you should get 50 times. Okay? An even number. An even number is a half a chance of getting an even number. Okay? So 300 multiplied by a half, 150 times. Okay, you get an even number. Find the word dealing. Okay? It has 7 letters. And in 7 letters, find the probability that the letter chosen is a G. There's 1 G, so it's 1 out of 7. Find the probability. This is very important, lads. A vowel or a G. There's 3 vowels. There's the E, the A, and the I. And then there is 1 G. So it's 4 out of 7. Okay. Shh. These number cards are shuffled and put into a row. John picks 1 card at random and does not replace it. He then picks a second card. His first card was 11. So the 11 is taken and not replaced. Find the probability that John selects an even number with the second draw. How many cards are left? 1, 2, 3, 4, 5, 6, 7, 8. 8 cards remaining. How many of them are even? 1, 2, 3, 4. He has half a chance of getting an even number with what's remaining. Okay? The first card, if the first card was an 8, so that means the first card was an 8, which means the 8 is now gone. Find the probability that he selects a number higher than 9 with the second draw. Has to be higher than 9. So 8 remaining. 1, 2. 2 out of 8, which is a quarter. Alright. Next one. Jane throws a dice, a red dice and a blue dice at the same time. Show all the possible outcomes in a sample space. Sample space means you start off with 1, 1 and you got to draw all the combinations out. Okay? So it actually takes quite long. You know what you're doing, but it actually takes quite long to do. Okay? So 2, 1, 2, 2, 2, 3, 2, 4. Okay, guys. Now what we're on next is a total of 10. To get a total of 10, you'll find is they'll actually occur in a diagonal. So 6, 4, 5, 5, and then the other 4, 6, 5, 5, 6, 4. You see that the combination of 10 occurs in a diagonal like so. Okay? So what happens there is there's 3 of them out of 36, and that gives you a 12th for the first answer. Okay? A total of 12 is going to be 6 and 6. It's going to be 1 out of 36, so a total of 12 is quite rare. A total less than 6 has to be less than 6, so we try and find 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's going to be 10 of them out of 36. Okay? So 10 out of 36, and 10 out of 36 is 5 out of 18. You got to reduce it down to its lowest fraction. The same number on both dice. It's basically the main diagonal here. So you can see this diagonal here. That's where all the numbers are the same as each other, okay? So that's 6 out of 36, which is basically a 6th. Alright, so that's, once again, quite easy, right? Now, number 7. Cleona picks 2 cards at random from the 3, 4, 5, and 6 of hearts as shown. Find the probability that the sum of the numbers on the card is more than 2. So what we have to do here is we're going to do a quick sample space: 3, 4, 3, 5, 3, 6. The next one is going to be 4, 3, 4, 5, 4, 6. The one after that is 5, 3, 5, 4, and 5, 6. And finally, last one is 6 comes first, 6 followed by 3, 6 followed by 4, and 6 followed by 5. Now, in this question we're asked how many of them is more than 9. So we'll circle the ones that are more than 9. 1. Oh, so that is 9. It wants more than 9. That's a mistake. 10, 11, 11, 10. It's going to be 3 out of 12, which is a quarter, because there's 12 of them in total. It's a quarter. Is there another one? Oh, sorry. 4 out of 12, which is a third. Excuse me. Okay. Next one. Marie made a 5-side spinner like the one shown in the diagram. She used it to play a board game with her friend Sarah. The girls thought it wasn't very fair as it seemed to land on some numbers more than others. They threw the spinner 200 times and record the results. The results are shown in the table. Work out, lads, experimental probability is a probability that you get from actually doing the experiment on it. So the first one, they spun it 200 times each. So the first is going to be 20 out of 200. That's for the number 1. So that's number 1, number 2, number 3, number 4, number 5. If some of you just get on the calculator just call out the numbers, that'd be grand. 1 out of 10. Sorry, 7 over 50. Perfect. Next one. Huh? 4 over 25. A quarter. And the other one? 7 over 20. Now guys, you could represent all of these in decimals if you want. Okay, so that's going to be what's that going to be? That's going to be 0.1. That's going to be 0.14. This was going to be 0.16. 0.25 and 0.35. If you've done them right, it should all add up to 1.0. Okay? Now, that's done, and we have our 2 sets of answers here. What we can do next is, how many times would you expect each number to occur if the spinner is fair? If the spinner is fair, there's 5 outcomes. So divide 2 by 5. Each one should turn up 40 times. Do you think the spinner is fair? Give a reason for your answer. I don't think the spinner is fair because I think that 70 times is way too high for spinning it 200 times in total. It's outside, a decent margin of error. So I definitely think that the spinner is not fair, it's biased, okay? Okay. Alright guys, another four-sided spinner is labelled 1, 2, 3, and 4. This spinner is biased. The probability that the spinner will land on each of the numbers 2 and 3 is given in the table below. What you know is that 100% is all the outcomes added together, and 100% is 1.0 in decimals. All of these together have to add up to 1. So 0.3 plus 0.2 plus x equals 1.0. 0.5 plus 2x equals 1.0. 2x therefore has to equal 0.5. X equals 0.25. If you're not happy with the decimals, another way of thinking of it as would be as a percentage. For instance, this one's 30%, this one's 20%. That means that that's 50% in total, which leaves 50% left. 50% is shared amongst the two of these. That would put them at 25% each, which is 0.25. Okay? Now that that's done, the value of x is 0.25. Sarah is going to spin the spinner 200 times. Work an estimate for the number of times it will land on 2. It lands on 2 30% of the time, or 0.3% of the time. 200 multiplied by 0.3, anybody? 60 times. Okay, so 60 times. Alright. Next one. The school snack bar offers a choice of 4 snacks. The 4 snacks are burgers, pizzas, pasta and salads. Students can choose from one of the 4 snacks. The table shows the probability that a student will choose a burger or pizza or salad. So once again, 35%, 15%, 20%. When you add that together, it leaves 30% left over. 30% left over is 0.3. Alright, 300 students availed of the snack bar on Tuesday. Work an estimate for the number of students who chose pasta. If they chose pasta, it's going to be 300 students multiplied by 0.3. That will get you 90 students. Okay. Next one. 30 students were asked the activities they enjoy from swimming. The 30 students were asked to state the activities they enjoyed from swimming, tennis and hockey. The numbers in each set are shown. One student is randomly selected. Which of the pairs of events are mutually exclusive? What mutually exclusive means is that for example, if 8 people do hockey and let's say 13 people do swimming, there's no overlap between hockey and swimming. Therefore, because nobody does both hockey and swimming, they're called mutually exclusive events. It means you haven't got a person that does both. Okay? So, an example would be if I was to use swimming and tennis isn't mutually exclusive because 5 people do both. Okay? So, selecting a student from S and a student from H. This is mutually exclusive because no student does hockey and swimming. Okay? Selecting a student from swimming and selecting a student from tennis is not mutually exclusive because basically there's students who do both tennis and swimming. Now, what's happening next is, what's the probability of selecting a student who enjoyed either hockey or tennis? Now, the problem with hockey or tennis is that we don't obviously want to double count. So, in total, there's 8 plus 15, 8 plus 5 plus 7. There's 20 people who either enjoyed hockey only, tennis only, or they enjoyed both. That still counts for them enjoying hockey or tennis. 20 students out of how many students in total? 30 students in total. This means there's 2/3 chance of picking somebody that likes hockey or tennis, or in some cases they like both. Okay? Now you could argue that if it's technically tennis or hockey, you could take out the 5 and you could say 15 out of 30, which is a half. You have to argue your answer, alright? Because the question is vague. Okay? So the question is saying, is it hockey or tennis, or does that include both hockey and tennis? In a test, I would answer both and write an argument beside both of them. Then the examiner will know this guy knows what he's talking about and should award full marks. Yes, Jack. Excuse me, guys. Hockey or tennis? Excuse me. I did swimming or tennis that time. Hockey or tennis is this one here. 10 people do hockey and tennis only. It says hockey or tennis. That doesn't include swimming. So we're going to go for 7 people who do tennis only. So that means it'll be 17 people out of 30 that you can pick who like hockey or tennis only. So the answer is 17 out of 30. Okay, question 12. A bag contains 2 blue beads and 3 red beads. Bag B contains 3 blue beads and 6 red beads. A bead is picked from random at each bag. Calculate draw a tree diagram for each one. Okay, blue, red, then the second bag can be blue or red, or it can be blue or red again. Now, in the first bag, the probability of getting a blue is 2 out of 5. The probability of getting a red in the first bag is 3 out of 5. Now, the probability in the second bag for getting a blue is 3 out of 9. The probability of getting a red is 6 out of 9. The probability of getting a blue in the second bag is 3 out of 9 again. The probability of getting a red is 6 out of 9. Now, what you need to do with each one of these is you need to multiply the fractions by each other. So what you're going to do is you're going to multiply 2 over 5, multiply by 3 over 9. And you're just going to keep doing this over and over again, and it'll reduce it to the lowest fraction, 2 out of 15. So this one's 2 out of 15. The next one is 12 out of 45, which is 4 out of 15. The next one after that is 9 out of 45, which is a fifth, or 3 out of 15. And finally, the last one is 3/5 multiplied by 6/9 is going to be 18 out of 45, which is going to be 6 out of 15, or 2/5. And all of this adds up to 100%. Now, question, what are the probability that both discs are blue? Blue is 2 out of 15. What's the probability that both discs are red? 2/5. What's the probability that both discs are the same color? If they're the same color, you can have blue or red. So add the answers of the first 2 questions together. 2 out of 15 plus 2/5. Okay, so 2 out of 15 plus 2/5, 8 out of 15. Okay, next one. What is the probability? Okay, next one. What is the probability that both discs are the same color? We just did that a second ago. It's going to be 8 out of 15 when you add them together. Now finally, what's the probability that both discs are different colors? Well, you can have different colors in 2 ways. You can have blue-red or red-blue. So that's 4 out of 15 plus 3 out of 15, which will get you 7 out of 15. Okay. We'll end it there, and I'll get number 13 on.